A little bit about how you come to be with Bear and what your position is and all that.
Yeah, I will. Okay. Before I do that, I'll skip past the title slide. And I have to apologize, I did come with enough material for an hour and a half, so I'm going to have to, I've got my timer set for 15 minutes. I'm going to cover some non-pesticide related things for 15 minutes, and then we'll try the pesticide stuff. We'll see if it's too much, but I'll try to address some of your questions. I know I've done this talk so many times or addressed audiences like this, and I know you do have some burning questions. Actually, Tim asked me one right off the bat, and I couldn't answer it, so I'm just preparing you for the fact that I may not be able to answer all the questions, but if we can't, we can find out the answers, so we'll be happy to record them, or you can submit them on a sheet of paper or whatever, or email them to me, and we'll see what we can do. Before I do that, Tim also said that the topic that he suggested was chemicals and bees living in harmony. I usually talk about the best of both worlds, healthy crops and healthy honeybees. And so that is the overall theme, but I'll have to select key components of that to keep it within the time. Now this is the background part, so you know a little bit more about me. I've been keeping honeybees for 41 years this year. I started in 1973 in Nova Scotia, Canada. At that time we bought our bees from Georgia and southern U.S. states, and we operate them during the summer. We usually get 60 to 100 pounds of honey, and then we go out with cyanogas and kill them off in the fall. Always nasty business. Then mites appeared in the U.S. and our supply was cut off and we had to learn to winter. So I've been wintering bees since the 80s, and it's a much better way to keep bees than trying to kill them off and buy new ones. Also, I've been an apiculturist for the province of Nova Scotia for 13 years. I kind of got out of beekeeping myself because I had provincial bees to look after and I had 500 beekeepers to look after. And you can just imagine multiplying this group by whatever number to get 500. It's quite a large number to address all the different concerns and wish lists that you might have. So it was a big job. Also, I've been a contractor for 20 years, and I did a lot of honeybee research, starting back in 2000 especially. I've been doing very intensive studies on honeybee health, trying to determine background of what's going on with honeybees. So I joined Bayer in 2009 because I had just finished doing a number of projects around the U.S. and in Canada, and I loved doing it, but it was keeping me away from home 100% of the time. Working for Bayer, I thought would give me an opportunity to help beekeepers even more because I could, use their infrastructure instead of my own cash. And also, I thought I'd be home a little bit more, but unfortunately that's not true. Beekeeping just keeps you hopping all the time. So I've been all over the country. The beauty of it is I'm visiting U.S. states that I'd never ever get to if I hadn't been in beekeeping and bee research. So I really, really enjoy it. And I love talking to beekeepers, so it's a great opportunity. And because I do a lot of hive investigations, it occurred to me one day that since I've been a scuba diver, it seemed like I was getting dressed for a deep water dive, protecting myself from these Africanized bees, which I was studying, and I was spending up to an hour and a half inside the hive. So it just occurred to me that, gee, I'm really a hive diver. I'm not a beekeeper, I'm a hive diver. So that's what I kind of call myself. So this is the outline of what I'd like to talk about, although I won't be able to cover it all. First, apiculture and agriculture in perspective. I would like to touch on that for sure. Honeybee health update, there are aspects of that I'd like to touch on. Then the crop and bee protection products, that's where the chemicals come in, and so I thought I'd give you a little pesticide toxicology 101 course, and we'll see how far we get with that. And then I'd like to talk about the solution to bee health, problems, and if there's time, we can talk about the bee care program as well. So, apiculture and agriculture in perspective. Of course, you all know that beekeeping is apiculture, but I'm not sure everybody appreciates that apiculture is also an agricultural pursuit. And one of the things I discovered when I was going around the country trying to help people, and they always want recommendations, is that North America is a continent of extremes. So this is just an example of one day I was in Florida in December, tearing these hives apart, investigating them, looking for problems. The very next day, I had to fly to the Midwest, and I was giving a bee talk, but I was freezing up there, and I wanted to go back to Florida. But it's just an example of no one recommendation is going to fit either apiculture or agriculture. It's a very complex thing, so you have to adjust your recommendations based on the region that you're working in. So, like I said, apiculture is agriculture, and the reason I say that is there's a number of reasons, but if you just look at a very simple definition in the dictionary, you'll see that apiculture is an art, science, business of managing honeybees for both products and services and livestock. If you look at the farming definition, same thing, art, science, and business of producing, cultivating soil, producing crops, raising animals. So they're very similar definitions. Also, there's a third component here. The crop and animal protection industries supply products for both of those, and both of those agricultural pursuits require some methodology, either methods or products to manage pests and problems. And so if those products are needed, then that's where the industry comes in as well. Also, industry produces seed for crops, and those crops require pollination. So if we're producing seeds to sell to farmers, to produce crops, you need to pollinate those crops. And Bayer actually produces canola seed, and they use the most bees, most hives in Canada of anybody in Canada. Something like 50,000 colonies are rented by Bayer every year to pollinate canola crop, and that crop is uses treated seed just like corn and soybean as well. So it works out very well for everybody. Honeybee health update. We'll get into what things bees need to survive. And I think as beekeepers, this is one recommendation that applies to everybody no matter where you are. Bees need the same things to survive that we do, and that's food, shelter, and safety. And when I'm in a fancy hotel at a conference, I will compare being locked into that fancy hotel, but you know, I prefer to be locked in this building and have a chef out back cooking away there. But if somebody did lock us in this building, I think we'd be quite happy here if we had armed guards all around, protect us from any marauding individuals, we'd feel safe. But, oh darn, they forgot to stock the fridge and can't get out to buy groceries, I don't think we'd last very long. So it's the same thing with honeybees. They have to have all the elements of these three categories. And so the recommendation is, when you're looking at your bees, always be assessing them for food, shelter, and safety. And you can easily make a list of everything under each of those categories that bees might need. Just do a checklist. And eventually, in your mind, you'll be ticking them off. You'll be assessing your bees as you enter the bee yard and identifying things that might be deficient. So, and the thing to keep in mind is they need all of those elements. And if anything's missing, then you could have problems. And that's the key. Look, you need to check every box in your list. And if anything's missing, then you've got a problem. So is there really a honeybee health problem? Well, I think we'll all agree, yes. And I agree, yes, there is. Honeybees have health problems, for sure. And this is just a very quick or simple summary of some data that I collected over a 4-year period. I actually collected data since 2000 to the present, but I've extracted 4 years of data, 2005 to 2008. And I have this system for assessing whether they are healthy, developing issues, serious issues, or dead or dying. So using my system and all of the hives that I assessed, which was literally thousands over the years, I determined that 18% could be considered healthy. So that's only somewhere around a fifth of the hives I looked at could be considered healthy. That's kind of low. Then another 30% had developing issues. In other words, those hives had something in there that could become a problem. Maybe not right now, but eventually it could. So those 30% were in that category. Then 27% on average had serious issues. Serious issues require extreme management. So that's, if you go out and look in your hive and you determine that it's serious issues, if you just say, well, I'll come back next week and fix it, that's not good enough. You need extreme management. And it might involve a number of different tactics, products, or even culling of hives. And finally, 26% were dead or dying. And this is just randomly going out, looking at hives, and this is what I found. And I've been able to predict or forecast winter survival from the same data. And I was predicting 50-60% losses on average over those years, and absolutely that's what happened. So you can look at the normal expected losses if you don't fix the problems in your hives should be, on average, 50-60% losses over a winter period. And the reason we don't always have that is because we're learning to control the problems better, we're doing a much better job, and so we are able to reduce that better than we used to be able to. The problem is some of these things cycle, like varroa mites cycle, maybe get out of control before you know it, so there are some years when we will have even higher than 60% losses. So that's just a taste of that. What are the causes? Well, it would be a great exercise for you as well. It's just to sit here in a meeting and brainstorm a list of all the things that can affect bee health. I bet you could come up with at least 30, 40, maybe even as high as 60 things that negatively affect bee health. So, and then if you put those in categories, you very soon find out that they fall into management categories, environmental categories, and in-hive categories. So, I can't think of anything outside of those three categories, but it just goes to show that there are a lot of things affecting bees, and if you want to understand what the problem is, you have to be able to assess all of these. So monitoring is key for doing that. In my efforts to monitor hives over that period since 2000, it's become very, very clear to me that varroa mites is the #1 enemy of honeybees, and USDA's made that announcement recently from a workshop they did. And a lot of groups are coming around to admit that. And I'm a little bit surprised it's taken everybody so long to figure out that varroa mites are the #1 blood-sucking vampire of the bee world, but because they were killing bees when they were introduced to the U.S., whole apiaries were being decimated. In Canada, the same problem, and also with trachea mites. Here we are with varroa mites virtually in every hive, and so now we have this developing issue in at least every hive, so really there are no healthy colonies. So that's what we're working with, colonies that really have the potential to become very sick. So we have to be able to look after those hives because they are in an unhealthy state. This is the critter, you won't dwell on those. This is a Wake County exhibit. I thought that was pretty innovative. The other thing with varroa mites is they carry viruses. One of the worst is deformed wing virus. And this is the first description and observation of deformed wing in queens. And I had the good fortune of finding this in Prince Edward Island, Canada, and we wrote a paper about it. But before that, people had not reported seeing the symptoms of deformed wing in queens. It affects the workers for sure. Everybody's seen the curly wings on bees. That's deformed wing virus. But the fact that it affects queens, it could be a very serious factor involved in difficulty with having queen issues in your hives. I'm sure all of you have had queen issues from time to time. There are a number of reasons why that could happen, but one of them is deformed wing virus. American foul brood, don't forget about this. Just think back before varroa mites showed up on the scene. What was the worst enemy of honeybees? American foul brood. How many times do we talk about it now? Very rarely. I did inspections in the Canadian province on American, well, one of the things I found in that province was American foul brood outbreak, partly because they had forgotten all about it. So that's my time on bees, but I'll just quickly zip through these slides. Tracheal mites, don't forget that either. That is one of those things that is present out there, and it can get out of control. Nosema ceranae. I also was involved in the first detection of this microsporidium in the Midwest and in Canada. It has bee health implications. Here's something, small hive beetle, I'm sure you've all seen that. And when we're doing the monitoring, we're also looking for residues. So we've done that constantly over the years, looking for that link between pesticide exposure and bee health conditions. And it costs about $300 to do each of these samples for a pesticide screen, so it's a very expensive proposition. About hundreds of thousands of dollars have been spent on this kind of monitoring effort. While I was traveling to Apomondia in Ukraine last year, I talked to a number of different country reps, and they were reporting that the causes of their losses, which were reported in posters and papers and presentations, were varroa mite, eczema, viruses, queen issue, starvation, weather, knowledge of beekeepers. As beekeepers, you have to become more knowledgeable than ever before, so that's a challenge that you really have to take on yourself. And operational factors, which I'm not sure what they meant by that, but certainly some other issues. So the bottom line is there are many things that affect bees besides just pesticides. I've got pesticides down here as well as bee and crop protection products, because both can affect bees if there's sufficient exposure or misuse. So as beekeepers, if you're putting chemicals in your hives, like pesticides in your hives for controlling mice or whatever, that it can be just as bad as some unintended exposure to some other products used for crop protection. So here's an example of something that's just demonstrates that correlation is not causation. And I think you'll often hear people say, well, I saw this, so it must mean that. Well, that doesn't necessarily hold true. This is an example of the bottom line is the juvenile arrests for possession of marijuana. So over the years it's increased, and then the honey production in bee colonies decreased over that same period, so there's a negative correlation. So if we could reduce the possession of marijuana, then bee health would improve, or honey production would improve. Me. Very quickly, this is just the system I use for assessing hives. I use a stratified provisional threshold system. I color code it just for fun. These are the definitions. I produce tables of thresholds for all the different things I look for, and they're again stratified in 4 categories. And this isn't carved in stone. It changes based on the region you're working in, expectations, the purposes. I mean, a whole slew of things come into play for establishing thresholds. But this is just an example of what I use. And using that same system, looking at some hives that migratory hives I followed from Florida up the coast and back down again, a lot of work over the course of the year, you can see that the quality of the hives starting in March were pretty good, but by October, it was pretty bad. And in fact, 80% of the hives died, and that's exactly what the data, by spring, and this is what the data was saying. 80% are going to die by spring, and they did. So I was quite happy that the data was, talking to me the way it was, but I wasn't very happy because the beekeeper didn't like losing 80% of his hives either. the reasons behind that, bromites, nosema, and management. And there's a number of different aspects of management, but and that's hard to hear though. As a beekeeper, you don't like to hear I did anything to my bees that might affect them. So are colony numbers up or down? Well, contrary to what you might read in the newspaper, colony numbers globally are up by 45% since 1965. In fact, they're up in the US, so that they've stabilized, and they're slightly up in Canada. There are more honeybee colonies there than ever before. Florida has increased by over double. It's over doubled since 2006. Illinois has increased, and so it is possible to keep bees even in these difficult times, but it takes a lot more effort, work, expense. In Europe, the most recent data produced by the Colas Group for the winter of 2013-2014 is showing that winter losses averaged in these 17 countries at 9%. Wow, that's exactly what we want to be at. We want to be in that range, 9%. So in Europe, I think I've heard them say the bees are all dying, they're in decline. Well, how come they're only suffering 9%? It shouldn't be in decline. So again, you have to read the media reports and the literature with a very critical eye so you understand all of the implications. Honeybee forage considerations, I am going to skip over this part. I would love to talk to you about that sometime. It's one of my pet activities. But I want to mention apiculture is in transition. So as beekeepers, and especially as hobbyists, you like to produce honey, #1 product. And that's what we always used to do. Back in the old days, honey was the main product of beekeeping. So this is what you'd see in some of these old farms. I actually had to inspect these hives, and that bottom box is where I had to be. Well, it wasn't a very pleasant undertaking, but that doesn't happen very much anymore. So, but honeybees also produce wax, pollen, propolis, bee venom, but most importantly, they're pollinators of our crops. That is the #1 reason for the importance of honeybees. And not only for directly pollinating a fruit, but also for producing seed to produce that we can sell for producing crops, such as canola or other seed crops, vegetable crops. So we're in this transition from honey production to pollination services. And in fact, almonds uses 1.6 million hives of the 2.6 million hives in the U.S. So that's a very significant number. I know it's all estimated, but it's based on the best numbers that exist. I think the 2.6 million hives in the U.S. is actually low because there are hobbyists and feral colonies, but how low, we don't know. And almonds are expanding, demand is increasing. Already next year they're expecting 1.7 million colonies are going to be created. So this is the transition we're going through. Also, I hear people who are losing hives say, well, you know, I kept them for a couple of years and so something's changed this year, my bees died, something's changed. Well, I suggest that you look further back than just the current year that you have problems, because back in the mid-1980s is when things really changed for the whole industry. That's when trachomites were introduced, bromites, nosema ceranae, new viruses and more efficient transmission of those viruses, small hive beetle, the shift from honey production to pollination services, the move away from small-scale operations to very large operations. There are actually more hobbyists now than ever before, so that there is a movement for people to get into beekeeping. But the only caution there is that is great, but because of the challenges, you as new beekeepers have to very quickly ramp up your knowledge and understanding of what you're dealing with. Because it's very easy to lose your bees and you have no clue what's happened to them as a result. So the challenge is to know the biology of the honeybee and everything that can affect it to a very high degree. This is a small bee yard in Newfoundland, Canada. They only have 2 months of suitable weather for bees. They produce up to 300 pounds of honey per hive. They have a very intense foraging time during those 2 months. They winter them in that environment where they have 10 feet of snow for a part of the year. So weather is not really that big a deal. You have to manage them in the right way to get through that kind of a climate. But the fact is, that's how we used to keep bees, small apiaries for honey production. Now we're keeping them in large numbers on monocrops and putting them in crops at very high densities, so there's not enough forage for them. This is almonds. Do you see any forage for those bees? Except on the trees, but they're only blooming for a couple of weeks. Also, this high density is causing a lot of mixing. If you were to write a book on the best management practices for beekeeping, would you put in there, move as many hives as you can into this apiary, like thousands, and let them loose, and don't feed them, and just let them fight it out for what is out there. You'll soon find that that's not the best thing. It's not a good management practice. Beekeepers do it because they're forced to do it. That's what we have to do to pollinate crops. But there must be a better way. So that's one of the challenges. How can we pollinate crops? How can we use honeybees to do it and not put them in this very bad situation where they're mingling, spreading diseases, robbing from one another, drifting from hive to hive, and suffering nutritional issues. Also, just getting the bees to the crops is hard on bees. Here we're mechanizing honeybees. We're loading them onto pallets in multiple colonies. We're hoisting them around on forklifts. The frames are moving. We're crushing queens. We're leaving bees behind when we pull the truck out of the yard. Again, that would not fit into a best management practices guidelines, although we have to do it for business reasons and to meet the demands of pollinators. Pollination. How am I doing for time, Tim?
No, you're good. You got 15 minutes.
Okay. Shucks. Give me an hour. This is an example of a holding yard for bees prior to the blooming of almonds in California. This is a valley which extends way beyond our field of view here. It's full of hives. You can see them in groups of 500 colonies per group. There were 50,000 colonies in this valley. There's not one stitch of food for them. There wasn't one single flower. They were so hungry, they came up, they thought I was something sweet and flowery, so they came up and were checking me out, but they were very soon disappointed with that. But this is a system that's, again, required for business reasons. What are you going to do with 50,000 colonies and no place to put them? If you get a nice valley, just move them all there, and then you have them all in one place. It makes management a little easier, but there's a lot of mingling. So I won't go through the problem with pollinating almonds in California. But the bottom line is, hopefully you see that raising bees at the commercial level, at specialty, is the same as keeping livestock. So you don't put 100 cows on a 1 acre field, you put a couple of cows on a 1 acre field. So here we're keeping hundreds of thousands of colonies in an area that can't sustain it. It's the same thing. Livestock is exceeding the resources to feed. So as a beekeeper, or as a farmer, you are in charge of managing them, providing all of the needs of the bees. That's the food, shelter, and safety. And that's why beekeepers have to be outstanding in their field, just like farmers do. The challenge of feeding the world, basically there's only a certain amount of land on Earth suitable for farming, and that is about 15 million square kilometers, or 1.5 billion hectares. And since 1950, human population has grown from 2.5 billion. It's estimated to be over 9 billion, maybe close to 10 billion by 2050. Land area has not increased for agriculture, so how are we going to feed that many more mouths? The only way is to increase yield. You can't increase yield without protecting the crops from pests and diseases. So that is a huge challenge. Crop and bee protection products. This is the part you've probably been waiting for. Just a couple of clarifications or definitions. First, we talk about chemicals all the time. Well, if you think about it, everything is made up of chemicals, and even cooking in the kitchen is using ingredients that go through chemical changes to produce the product. So chemicals and chemistry is all around us. It's everywhere, it's everything. So I would suggest that we stop using the word chemical and talk about pesticides. But then even that is kind of tricky, because what are pesticides? Actually, it could be synthetic products, it could be organic products, it could be soapy water, it could be a number of different very harmless things, and ordinarily things that we even eat could be turned into pesticides under the right conditions. So the point with saying pesticides is to be clear on what you mean. If you're concerned about a crop protection product and say it's a crop protection product, say it's neonicotinoids, even that is a category of the products. So it's important to understand what is a pesticide, what are the different types, what are they used for, and you may even use pesticides in your hives for controlling different things as well. So pesticides are, 10 minutes, awesome. Another thing to understand about pesticides is that they're all, except maybe some of the organic or homemade brews, are not assessed for risk, but commercially products are assessed for risk. Risk is simply how toxic is a compound, so that's the hazard, and how much exposure do you expect to have. So it's that function of hazard and exposure that produces the risk value. And a good example of that is, here we have a very hazardous organism, the lion. If that lion was allowed into this room, it would be very hazardous and we would have high exposure, so the risk of us dying is very high. However, if we had that same lion, which is still hazardous, brought into this room in a cage, the exposure would be low, the risk to us would be low. So that's how chemicals are studied to produce that low risk, even with a toxic material. Again, lots of words. I won't get into all of that, other than to say that there's a lot of testing, both in the lab and under controlled semi-field conditions or field conditions. And there's lots of improvements in that testing system. There's lots of regulation. There's lots of reviewing them periodically. So all of this is being done all the time. Seed treatments, actually, in my opinion, this is the most significant advancement in pest control ever. It's using a toxic material in a very low dose, put on seeds. It's only applying it to 1% or less of an area of land when it's used, versus a foliar application, which would actually be multiple applications of foliar products to be equivalent to this, would be over 100% of the land, and even more than 100% because of potential for drift and off-site movement. This is 1% or less, and it does a great job on early season pests that you would have to control by much more toxic means. And in corn, for example, I'll just say that there's 150 million acres of row crops planted annually. These include corn, canola, sorghum, and other things. And very seldom is there any bee loss as a result. I have to admit there are cases of unintended exposure under certain conditions, but that is solvable. Once you identify the problem, you can fix it. And so this is very little impact for a very huge return to help feed the world. It's kind of like driving cars that were designed to the top safety standards. There'd still be car accidents, and it just happens. So we have to consider that. This is how it works. It goes on the seed. It only affects the small area around the seed, and it's as the plant grows, it protects the plant in that very young stage. Beyond that, there's very little effect. And certainly no exposure to bees. These are some of the benefits. I just explained some of the benefits. One of them is at the bottom, low mammalian toxicity, so it's safe to applicators. It fits into IPM, even though people will argue that it doesn't because it's used almost prophylactically, but if you really look at it, you have to put something on at some point, so you might as well use this because it's effective and it's safe. And so it does fit the principles of IPM as a result. Skip that for now. I'd be happy to come back and focus on any one of these, but this is a point I'd like to talk about. You've heard of systemics. Well, 5 minutes left. So systemics are, neonicotinoids are systemics, and there are several different products. Systemics mean that you can put it on the plant and it moves inside the plant and up into the plant itself. So it's upward mobile, and that is through the xylem part of the system of the plant. Then there's a second system in plants called phloem. These products don't move well in the phloem, which is the system that reaches the pollen and nectar. That's why when we look at residues in pollen and nectar, it's way, way low, very low, below the levels of concern, because those residues are not reaching the food that bees might be exposed to. But any insects that feed on the plant are going to get toxic dose, especially in the young plants, early stage. So that's how that works. And because I'm running out of time, I won't talk about the residue levels, but that is definitely a course in itself. This is just a chart showing you that you are using pesticides for row mite control. We've got 4 listed here. The request from the beekeepers at a recent meeting I attended was, we need more chemicals for bees, we need more pesticides for controlling things. So the best thing companies could do is develop a new verocide. And certainly we're trying. It's not easy, but and we do need additional products to use in a very intelligent way for controlling these things as a tool in our toolbox. Not just as the silver bullet, but as a tool in our toolbox. One of the problems with using it as the silver bullet is because it might work, but then you get resistance development. And here you can see that fluvalinate is already only 45% efficacious. So that's half of what we like it to be. Coumaphos is only 34%. Here's an unregistered new product, flumethrin, not used in the US. It's only 40% efficacious based on studies so far. And that's because there's cross resistance. So this is not good. That's another reason why it's hard to develop new products. Here's some high-level best management practices for beekeeping. I will go through this. First, choose suitable apiaries. And I think I have a list of what to look for. Let's see. Also, choose your carbohydrates carefully and feed your bees when they need it. You may have to feed your bees 6 months of the year. You may have to feed your bees in summertime. I'm sure you're probably feeding your bees right now. You have to know when they need food. You have to supply the food. As a manager, as a bee farmer, you have to look after bees. And choose carbohydrates that are appropriate. You don't feed bees molasses. Anybody know why you don't feed bees molasses? It's sweet, it's sugar. So, yeah, there are impurities. What will happen? It causes dysentery and your bees will die. What if you heat your syrup to a high temperature for too long? What will happen? HMF formation, which is hydroxymethylfurfural. If you store your bulk food outdoors in a tanker at high temperature for a whole summer and then feed it in the fall, you will kill your bees because you're feeding them hydroxymethylfurfural. So you have to know that you're feeding your bees quality food. Monitor and manage pests early and using IPM. Manage using IPM. So don't just reach for a chemical to throw in your hive. Think of how can I manage my problem using multiple tactics in the most least toxic way. So that's the principle of IPM. Use generally accepted seasonal management practices. So yes, beekeepers are innovative and inventive and like to do things their own way, but please, there is a whole range of management practices from the worst thing you can do to your bees to the absolute best. Operate somewhere in the middle where it's going to be acceptable by everybody, and I think you'll have better luck. Or if you're going to experiment, do it as a legitimate experiment so you can draw conclusions about how effective that method is. Follow labels. Don't come up with your own doses. Requeen annually and use local quality stock. I'm sure you've heard that or promoted it in one organization. Have hives that are bee type, dry, appropriate size, and entrance size. And I've looked in so many hives that are rotten and have multiple entrances. And actually, if you try to pull them apart, pry the hives apart, they fall apart from dry rot. And you open the lid, and there's carpet nests in there, and cockroaches, and a whole bunch of things. That doesn't fit into this best management practices. Having one entrance, one primary entrance, and then a ventilation or temperature control entrance is good. But if you have more than those entrances, then you can't control what's coming and going, what's robbing, what's drifting, entrance points for pests and diseases. And communicate and cooperate. This is communication, what we're doing. Also, I see everybody working together and mentoring one another. That's absolutely fantastic, but let's do more of that. Crops also have best management practices, and we don't have time to go through this to any great extent, but one of the primary things is they want to do is ensure food security, and that's why we need best management practices, because we need to produce safe food that's doesn't cost all outdoors. It has to be affordable and it has to be readily available. So a lot of the best management practices are geared to that. At the same time, there's requirement for stewardship of the land, because it has to be a sustainable system. Farmers cannot farm for indefinitely if their farming operation is not sustainable. So that's a good thing to know that they're trying to be sustainable. So the solution, I'll have to skip that. That's a fun chart I'd like to talk about. But there are 7 components to the solution. So I know there is a solution. We can control and manage bee health very effectively. We do it in our own yard at Bayer. We've had 100% winter success for 2 years in a row. And we have problems, but we invest a lot of time and money in managing them, and that's what it takes. But if we follow these 7 components, we will have the solution to bee health. I don't have time to go through them, but the things that you can do as a beekeeper right now is to make improvements in 3 areas, and that is monitoring, management, and mite control. So just think about where you can make improvements in these 3 areas, and you will have healthier colonies. So I won't be able to go through this. My time is up. I'd like to answer some questions, actually. This is quite see if there's any last slide I'd like to show you. Oh, our Healthy Honeybee program is based on those 3 principles: monitoring, management, mite control. A lot of our research fits into those 3 categories. So this is some of the things we're doing for monitoring, some of the things we do for management, and also for mite control. And then we have a whole slew of other things that are peripheral to that and maybe lower priority in some cases. Okay, sorry. Any questions? Yes?
You said you had 100% overwintering success.
Yes.
How do you overwinter your bees? What, a single deep, double deep?
Single deep.
Single deep?
Yeah.
How much honey? How
We
much do you
feed
store?
them all they'll take. We even make them honey bound later in the season. And we feed right up till November. And then we start again as early as February. And we also control mites early. We actually need mites for doing some of the work, so we do push the limits on mite control, And right now, we're doing some work next week and some efficacy studies. But after that, we're going to control mites. And the reason you need to control them is to protect the winter bees. If you don't protect the winter bees, we use multiple tactics. One of them is severe splitting in the spring. We do live splits, and we treat them based on one half being queen right and broodless, and the other half is brood right and queenless, and then we time the control based on the expected development and when the most mites will be exposed to the treatment. So that's one thing, that's early season mite control. And then in the fall we use Avigard, which is fun. And I mean, it's not the most effective product, but it gives us, we don't want to kill all the mites either. So, and it's allowed us to keep our bees alive and healthy. Now, we do lose bees in the summer, and we do a lot of culling as well. So those aren't included in the 100% survival. There are in-season challenges that we haven't successfully addressed yet.
Any breed of bee, one breed better than another? Like Italians, Russians, whatever.
Well, you know, there are very few, if any, pure lines of anything around here because the bees are all open mated. So you really have hybrids everywhere. And some of the queen breeders may claim to have pure lines of Italians or whatever, and some of them do. But and if they are pure lines, they have different characteristics. Some are better honey producers, some are better at wintering, some swarm less than other ones. So I don't really have a recommendation on that because we don't work with pure lines of anything. We just work with hybrids. And if you can keep your bees local, raise your local queens, eventually you'll have better stock than you can have by purchasing pure lines from somewhere else in the country.
The reason I asked the question, I saw an article on TV this past week that said during the colony collapse disorder that these people raised Russians, and said during that time that there has no been a colony collapse disorder if they had Russian bees. Is that true or not?
I can't say for sure. I do know that Russian bees are more hygienic and tolerant of varroa mites. So that is their selling feature.
Okay.
And why you might want them. If that's the case, then, well, they may have survived just because they are better at controlling mites.
Okay.
And therefore they have fewer viruses. And as a result, they're healthier in the beginning. So,
Okay. Thank you.
yeah.
What do you feed your bees? What do you feed your bees?
Just granulated white sugar and water. And usually we mix, it's called 50% solution, but Jim does mix it up. It's thicker than that at times. 50% is, sorry, it's metric, but it's 1 kg topped up to 2 liters of water is a 50% solution. We use it because it resembles the sugar content in nectar, and a lot of our studies requires the feeding of something that's similar to nectar. So that's why we use that.
Is that just equal weight though?
I have been meaning to do that calculation, and I haven't done it yet. In fact, I'd like to produce a whole table of all the different ratios. There's weight, volume, weight, weight, percentage, so many different ways. There's brick scales. I haven't done that yet. Yes?
Early in your talk, you mentioned in Europe the survival rates are much higher.
Well, this past year they were.
Right.
They have.
I'm curious about, are there many feral colonies in Europe? And also about the wild forage on the sides of the roads and between fields and things like
In
that.
Europe or here?
In Europe.
Well, Europe has had high losses some years as well. And I don't know what their feral population is. I haven't seen any studies on that. I think it's the same as here. And mites has really done a job of eliminating a lot of our typical Apis mellifera western honeybees. The ones that are surviving in North America are Africanized bees. They do really well as feral colonies. As far as Forage goes, I don't think it's, again, that much different than here. I've been over to Europe a number of times, any different times of the year, and it feels like home to me. So, and I'm always assessing plants everywhere I go. Taxi drivers go along, and I'm looking at all the honeybee forage. So I haven't got the impression that there's any more in Europe than there is here.
Have you seen difference in your hive studies that people that have honeybee healthy or any products versus the hives that have not? You're seeing a balance of better quality or better stability with these?
I don't use honeybee healthy myself, and I've heard reports that testimonials that it's the best thing ever, and I've heard testimonials that it's totally useless. So I can't comment on that either. But in that case, I think you do need to try it and experiment yourself. You might want to try feeding it to some colonies and not others, but do some kind of measurements that can be compared. And then you might like better fit. Yes, we use Megabee. We feed that as long as they keep taking it down, but once they stop, we take it out because it gets infested with small mosquitoes. Yes. Yeah, we don't mix up. It has to be simple and easy for us, so we use pre-mixed patties. Just and sometimes we'll use a portion of a patty, so we might not know if they're going to take a patty, so we use a quarter of it or half of it to see what's going to happen. Yes?
I've only been beekeeping for a couple of years, but I've got a lot of crops all around my house, different kinds of crops and stuff.
Yep.
And I know you know what grow mine looks like and all that kind of stuff. But how do I know if a pesticide is affecting my bees? What does that look like?
Well, it's in an acute situation, it's not hard to diagnose. You will have a spike in intra-hive mortality. In other words, bees will die and be piled up in the front of the hive. And it could be several hundred or several thousand. If it's not an acute exposure where you get immediate bee death, then I haven't seen any symptoms other than maybe a slight increase in mortality and no colony mortality ever in a non-acute situation. So they recover quite quickly.
So is it dead or
Yeah, pretty much. Pretty much. People think that they will store it and eat it later and die as a result, but we've done a lot of sampling in hives of both nectar and honey and pollen. We can't find neonicotinoids stored in hives. If it is in there, it's at sublethal levels of less than 5 parts per billion, which is way below the F level, and that is rare finding. No, they're not storing it immediately. And the larvae are actually more resistant than the adults. So, anyway, one last question.
I didn't feed my bees over the winter last year. I just let them take what honey they wanted,
Yep.
and they seemed to do fine.
Yeah. And then come spring, like come March,
I
did
don't.
you feed them at all?
I've got where I don't feed them at all.
Well, then you must be in an area where you have not exceeded the carrying capacity of the forage, and they can sustain themselves without your assistance. And that is a good thing. But not everybody's going to experience that, unfortunately.
Well, yeah, I bought sugar about a 50-pound bag, but I've had someone out there far more experienced than me to say, okay, these bees don't
Yeah.
need to be fed anymore.
Right. Yeah. And if that's the case, then you don't need to feed them, absolutely.
And
But but you have to be looking to make sure that's the case. You just can't rely on it every year. How many hives do you have?
I had 10, but I lost 5 of them last winter. I've only got 5 now. What happened? I was feeding those. They were newly started hives, but they were there one day
Right.
and gone the next. They were there. I even opened up one box. Every bee in there was gone but the queen.
I have this saying or rule of thumb that about bee losses where you're unexplained bee losses. In my experience, based on frequent monitoring and intensive monitoring, I have not come across a bee loss that's been unexplained to me yet. And unless somebody calls me out, look at my dead bees and tell me what killed them, I can't tell you because it's a post-mortem, and I'm not good at post-mortems. I'm good at antemortem assessments, which is looking at the bees prior to death and telling you what's going to kill them. I can do that. But I can't tell you after they're dead.
They just left.
Yeah.
They just left.
Yeah. Anyway, is that it or?
Yep, it's 8:30, that's
Oh,
it.
awesome.
Thank you.
I have a ton more I could talk to you about, and I would like to go through apiary suitability assessment sometime. If you ever want to ask me back, I'd be happy to do that.
Thank you very much.
Okay.